So this is more suited for multiple choice style, and I don't know if whoever's making Google Forms for this lesson or this week may include anything related to this. But I want to make sure I talk about it one more time here. So suppose we have Mr. Tang and holding on to one end of a slinky, Zara holding on to the other end, and Mr. Tang's gonna make some disturbances on his end of the slinky. He's gonna move his end back and forth, and that's gonna cause this wave pattern to show up on the slinky. I'm doing it at a certain frequency, making some sort of a pattern, and then I'm going to change. I'm going to vibrate my end of the slinky at a faster rate. So what's that going to do to these 5 properties here? Well, the frequency, just by definition, is going to increase. The question basically says, what happens if I increase my frequency, if I vibrate it at a faster rate? And because my frequency increases, since the frequency and the period are reciprocals of each other, if I were to increase my frequency, that would cause my period to decrease. Okay, what about the speed that these disturbances are traveling from me to Zara? I don't know if you caught from a couple of lessons, but the speed usually depends on the medium that it's traveling through. In this case, the medium is the slinky itself. And I do not change anything about the slinky by vibrating it faster. It's the same slinky. It's stretched the same amount. It's like if I pulled it back more to increase the tension of the slinky, that might change the speed because it changes something about the medium. But that's not what's described here. I'm just vibrating it faster. So speed will stay the same. I'll elaborate down here. Speed depends on medium. Which is not changing in this situation. Okay, how about the wavelength? Well, we can use our answers from above to make a prediction about the wavelength. So we know the relationship between speed, wavelength, and frequency. This is an important formula. The speed of a wave equals wavelength times frequency. So the wavelength would be the speed divided by the frequency. So since the speed stayed the same as our answer to part C, and our frequency increases as our answer to part A, then our wavelength is going to decrease because the denominator of that fraction gets bigger. All right, so what it would look like actually, I'll draw another diagram here. So Mr. Tang's here, Zara's there. If I were to increase my frequency, I would keep the speed the same, but the wavelength shortens, so it would look something like this. My art skills were not that great for that one, but it's a shorter wavelength now and a higher frequency. Okay, and finally, the amplitude. The amplitude represents how far away from the equilibrium the maximum movement of the slinky would be. So however much that is would be the amplitude. Or on the other side, however much that is the amplitude. The same with my new wave. However much this is the amplitude, or that. And I think, don't let my diagram fool you. The amplitude actually depends on what I set it at when I vibrate it. So it's really how far my hand goes back and forth as I'm creating these disturbances. If I swing my arm way out as far as I can to one side and then as far as I can to the other side, that's going to make a higher amplitude, no matter how frequent I do it. So this one's really, we don't know the answer. It depends on how far Mr. Tang swings the end of the slinky. This is kind of a trick question there. Yeah, it doesn't give us any information about that, so we cannot know the answer to that.